Good evening, ma'am. Yes, you are audible.
Okay. So shall we begin?
Yes, ma'am. Okay.
Yeah. Okay. So my screen is visible, right?
Yes, ma'am. It is visible.
Okay. Thank you.
Ma'am, may I get a chance to say something before we start?
Yeah, sure.
So in the last session, which was being done by, I think, Shubham Maurya,
Okay.
we had put up the request that we want time to solve the questions, the activity
During the session.
questions, the activity questions that we have not been able to solve is where we need help. And
Okay.
Shubham Maurya said that from the next session onwards, which is today's session,
Hmm.
time will be devoted to solve the activity questions also.
Yes,
Is that the
definitely.
expectation in this session?
Yes. 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 So I have just added a few problems just to get an understanding of whatever topics we are discussing today, and then we will have, like, I think whatever I have will be done within an hour, and then after that we can do activity, like whatever questions you're having problem.
Sure, ma'am. Okay, thank you.
Okay, so in today's session, you would have already seen differentiability and how to check whether a function is differentiable and all that. So in today's session, we'll start by computing derivatives of different functions, and then move on to using the L'Hopital's rule for finding the limits, and then we'll discuss tangents and linear approximation. So yeah, so you just stop me and tell me where to go slow wherever you find difficulty. If there is some like if there is some topic where you don't need help, then maybe we can quickly finish that so that we can devote more time for your doubts. Is that fine?
Yes.
Yes, it is.
Yeah. Okay, so when do you say a function is differentiable at a point? So the function f is differentiable at the point a. When do you say this?
When limit x tends to a, fx is equal to fa.
No, that's continuity, right?
When a tangent exists.
Yes, fine, but with respect to the limit definition, like the actual mathematical definition.
When limit h to 0, x plus
Do you
h.
remember seeing this? Not x, this is a. H tends to 0. Yeah, right. Okay. Limit h tends to 0, f of a plus h minus f of a by
Divided
h.
by
When this
h.
limit exists, right? When this limit exists, you say that the function is differentiable at the point a, and this limit is the derivative of the function at the point a, right?
Yes, ma'am.
Yeah. So in the previous live session, you would have seen how to check whether a function is differentiable and all that. So in today's class, we will just continue from what was like from where it was left in the previous session. So yes, when you have functions, there are definitely things that come to your mind about sum of two functions, difference of two functions, product, and all that. So we'll discuss those for differentiable functions as well. So yeah, these are all pretty easy to prove just by using the limit definition of the derivative of a function. That if f and g are differentiable at a point a, then f plus g, the sum of the two functions f and g, is also differentiable at the point a, and their derivative, that is the derivative of f plus g, is equal to the derivative of f plus the derivative of g at the point a. Similarly, for difference, the same thing holds for difference too. So plus or minus holds. And then when you multiply the function by a scalar, if f is differentiable at the point A, then any scalar multiple of the function is also differentiable at the point A, and the derivative is nothing but you just pull out the scalar and differentiate the function at that point. So CF, the derivative of CF at A is equal to C times f dash of A. Yeah, we discussed difference. And then product. So you have two differentiable functions, f and g. The product is again differentiable, and the derivative of the product is called the product rule, and that's nothing but you keep one of the functions constant and differentiate the other function, and you do that for both the functions. So fg dash is f dash g plus fg dash at the point A. So yeah, this is the product rule which we will use in most of the problems. And then the quotient rule. If f and g are differentiable, then f by g is also differentiable, provided g is non-zero at the point where we want to find the derivative. And the derivative is given by this formula, the quotient rule. So the denominator is square of the denominator function at the point A. So g of A squared. And then the numerator is f dash g minus fg dash. So these are things which you must have already seen in school. So we'll just skip those.
I have a doubt here.
Yeah.
There are certain questions in which the f is actually a product of two different variables, and the quotient we have another. I mean, that is divided by another variable down. So in that case, do we use both product and quotient rule? I mean, I get confused in such questions which are there in activity, as well as the
Yes.
assignments as well.
Yeah. So suppose you have fg by h, then for fg you will use product rule, and for fg by h you will use quotient rule. So when you have f into g, suppose I mean f, g and h are all functions. Okay.
Mm-hmm. Mm-hmm.
So for this fg by h, that is a function, right? So
Yeah.
for that you will use quotient rule. So you will have h squared in the denominator, h fg derivative minus fg and h derivative. This is quotient rule, right? Yes or no?
Yes,
The
yes.
numerator is fg and the denominator is h. So this is the quotient rule for fg by h. And then at this point, because you want to find the derivative of a product of two functions, you will apply product rule.
Okay, ma'am. Yeah, got it. Thanks a lot, ma'am.
Yeah. So it doesn't depend on what the function is or anything. Wherever you want to find the derivative of a function divided by another function, you will apply quotient rule. And wherever you want to find the derivative of a function multiplied by another function, you will use the product rule. Just like how we did here.
And ma'am,
Because this function is divided.
is there some exception where instead of the quotient rule, like we can inverse the quotient and multiply and apply the product rule? Is there some exception to any function where we should not be doing this?
No, it's always the case, but you can do one thing. So fg by h or even f by g. Let's take f by g.
F by g, exactly.
You can also view it as f into 1 by g, right?
Correct, right. Or g inverse. F into
so
g
here
inverse.
You can apply. No, g inverse is different. 1 by g is
g minus 1.
Like,
g raised to power minus 1.
No, like with respect to functions. So if you have the domain and the codomain, so g, if it is a function from here, g inverse is this. G inverse is this, a function from the codomain to the domain such that g into g inverse is identity.
Okay.
Yeah.
Okay, then we should be taking f into 1 by g and then apply the product rule.
Yeah, so f is a function,
fine.
1 by g is a function. So to find the derivative of this, you can use the product rule.
Product rule. Okay,
whatever you do for this, applying the product rule, you'll get the same answer that you will do for this using the quotient rule.
Quotient rule. Okay, ma'am. Thank you.
Yeah. And then you have composition of two functions. So yeah, addition, subtraction, scalar multiplication, division, and then composition. These are the basic things that we discuss about functions. So yes, for differentiable functions too, we can talk about the composition and the derivative of the composition. So if f and g are differentiable, then the composition f of g of x is also differentiable, and the derivative is given by this. So f composite g dash is f dash at g of x into g dash of x. So this is the implicit differentiation where probably most of you are missing out this g dash of x. So yeah, with respect to composition, it needs to be noted that you differentiate f at the point g of x, and then you differentiate g at the point x. That is the derivative of the composition f composite g. So if you write it without x, it will be something like this: f dash at g. Yeah, it doesn't make sense to write like this, at x into g dash of x. So this implicit differentiation, this is something, this g dash term is missed out by most of you, so you should be careful when you do this. Yeah, and then derivatives of some functions, which you must be knowing pretty well by now. So if you have f of c of x, where c is a constant, the derivative of this is going to be c times f dash of c of x. Can you tell how we got this? By using what rule?
Composition chain.
Yeah,
Is the constant one.
yeah, c is a constant, but you're actually doing this implicit differentiation. So what you do is you first differentiate f at the point wherever you want to differentiate, and then you differentiate what is there inside also.
Yes.
So you have f of g of x. So for what you do is first differentiate f at the point at g of x, and then you differentiate what is inside. So when you differentiate cx, you get c. So that is how you get this derivative. And then x power n for any polynomials. This is an important thing that we need. So the derivative of x power n is n times x power n minus 1. So 1 degree lessons, and whatever is the degree that we started with comes as the coefficient. So n times x power n minus 1 is the derivative of x power n. And what is the derivative of sine x?
Cos x.
Yeah. And when you have sine ax, again you use the composition thing, right?
That is
So
cos
you
into
first,
a.
yeah. So you will first differentiate sine ax, means the sine part, that becomes cos of ax, and then that ax, you need to differentiate the argument also. So when you differentiate ax, you get a. So the derivative is a cos ax. And the derivative of cos x is
Minus sign.
Negative sign.
Minus sign x.
Yeah, it's minus sine x. So you do the same thing again. So for cos ax, you differentiate the cos part. So that becomes sine minus sine ax, and then ax needs to be differentiated. That will be that will give you an a. So the derivative will be minus a sine ax. What is the derivative of e power x?
E to the power x.
Yeah, it's itself. The derivative of e power x is itself. So again, when you have an a, it's the same thing. You need to differentiate the ax part again. So for that, you'll get a constant a. What is the derivative of log x?
1 by x.
1 by x.
Yes, it's 1 by x. So when you differentiate log ax, what do you get? The log part, when you differentiate, you'll get 1 by ax, right?
1 by
ax.
Yeah, 1 by ax. And then you need to differentiate this ax part. So for that, you will get an a. So you can cancel out this a. So derivative of log ax is also going to give you 1 by x. Fine?
ma'am.
Yeah.
Is there any difference when the base of the logarithm changes, either log or
No,
tan or
it's
2?
it's just the like this is natural logarithm. So when you differentiate natural with respect, when the function is log x, natural log x, you get the derivative of as 1 by x. When the base is different, you can write it in terms of another base, right? Like the change of base rule. So you have log a to the b, log a to the base b. This can be written as
ln a by ln b.
Yeah, ln a by ln b, or in fact, you can, this is with respect to any base. Yeah. So in particular, we can choose base e, natural logarithm. So you can write it as ln a by ln b. So this is all going to be e, right? So is it really necessary to find, understand or to know the formula to find the log ax to the base b?
Ma'am, am I audible?
Yes, you are.
Ma'am, I have a doubt. If suppose you have, I mean, for that fifth one, e raised to ax, suppose if I have a
Yeah.
function like e raised to x cube minus 1 or something like that. So again, I
E
do
raised
that.
to x cube minus 1. Yes.
So do I do that implicit differentiation the same way? I mean, I do e raised to, I mean, I have x cube minus 1
Yes,
into e,
definitely.
it happens the same way, right?
Yeah, that's because you know e power, the derivative of e power x, right? So can
It's
you
the
see
same.
this function? Yeah, it's e power x. The derivative of e power x is e power x. And you also know how to differentiate when there is composition, right? Like when you have f composite g of x. So now if my f of x is equal to e power x,
Yeah.
and g of x is equal to x cube minus 1, now you know to differentiate f of x and g of x, right?
Okay, okay, okay. Yeah.
And you know how to differentiate f composite g of x.
Yeah. So
So
we
what
use
is
the
f
same
composite
principle.
g of x?
It
It
is
will be
f
f
dash.
of x cube minus 1, that is e power x cube minus 1. This is the function that you need to differentiate now.
Correct.
And you know how to differentiate f
Yeah.
composite g.
Okay. Okay. Yeah, got it, ma'am. Thank you.
So it will be 3x square into e raised to power x cube minus 1, correct? The differentiation
Yes.
of it, right? Okay.
Yeah, you have e power something. So the derivative is going to be e power that
Same.
thing only. And then
And then
because
we
of the
x
composition
cube
thing,
minus 1.
you need to differentiate this part. So that will, whatever it is, x cube minus 1. So that will be 3x squared. Yeah, just 3x.
Ma'am,
Yes.
but there would be one more g dash x, right? I mean, what about that?
Yeah, this is the g dash x, right?
Okay.
Okay, let's go by this. So what will you do? You will first do f dash at g of x, right?
Yes,
And then
ma'am.
you will do g dash of x.
Yeah.
So what is f dash? F of x is e power x. What is f dash?
E power x. Yeah. 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 Okay.
Yeah, but you need to apply e power x at g of x.
Yeah.
So that will be e power 3x cube minus 1, right?
Okay. Yeah.
And then g dash of x is going to be
3x square. Yeah, got it, ma'am. Thanks a lot.
Yeah. So this implicit differentiation. So whenever you have this ax, some coefficient for x and all that, that's all coming because of this composition, the chain rule that we are applying. Because you can see such functions as a composition of two functions whose derivative you can easily calculate. Yes, there is someone with a question.
One question.
Yes.
If there are two variables in the power also, like x square minus 3 and whole to the power 1 by x square.
1 second. X squared minus 3.
3 and whole to the power 1 by ln ax.
Okay.
Ln ax. Then here also we can treat x square minus 3 as a composite function and treat x to the power n 1 by ln ax into x square minus 3 to the power 1 by ln ax minus 1, like that, like a polynomial function. Can we treat like a polynomial x to the power n? Can we compare with this x to the power n?
No,
Or
are you asking if you can do
like this
1 by log ax minus into x squared minus 3 by.
Yeah.
Are you asking this?
Can
No.
we do like this, or what
No,
to do?
you
in
cannot
this
do
case?
this
Okay.
because
Yeah.
I told you that the derivative of x power n is n into x power n minus 1,
Okay.
where this n is a number and log x, this is a function, right?
Okay.
This is not a number. Yeah, so
Then
you cannot do that.
In such cases, where function is the power of the function, then how to differentiate or do like the simplification?
So this again, you will convert it into a composition of two functions.
Okay.
You'll write it as f composite g, but this is going to be like uh, pretty.
How to approach like in such cases where the standard method of approach where two functions are composition in the power also and log is also there.
Yeah, so differentiating this function is going to be pretty tricky. The best way to go will be by using the definition, like the limit definition and all that.
Ma'am, we can take
Can we
log
skip this
in
because it might be confusing and it might
Ma'am,
confuse others?
Yes,
we
please.
can take
Yeah.
this function equal to y and then take log both the sides and solve it.
Yeah. You have to do something like that only. Because it's like a function and the power is also a function. So the best thing you can do is by taking log, differentiating both sides, and then finding whatever f dash that you needed and all that. Yeah. So basically you can take y is equal to this, and finally you need to find out y dash. Okay. Should we do it?
Okay.
Or can we?
Okay.
Okay. So y is
We
equal
have
to
these
this,
kind
and
of
then
questions in our assignments.
oh,
This
it's
type of
there. Is it
question-
okay?
Yes, right.
This type of questions are there in the assignment and nowhere it has been given how to approach. That's why
Yeah,
this
so
Okay.
he's
Okay,
not
let's do
directly
it
asking
then.
the question, but it is the kind of
Don't-
approach
yeah.
which we all have
approach
doubts with, right?
nowhere it has been mentioned, ma'am. So we are not able to solve this. This is the
Correct,
only
right,
question
right.
we are not able, and such type of question is there in that. Am I right?
Okay.
Okay, ma'am. Just I put the question so that.
Okay. Can we make it a little simple?
No, simple is
It's
there.
the same. It's a procedure is the same, but I don't want. I like. Okay.
I
Let
get-
me see if I've added a rough page so that we can.
That
do
was
it
simpler.
there.
In the
Yeah.
assignment, it is simpler, ma'am. But I put the harder one.
Okay. So what was the function? It was x
Let
cubed
me
minus.
let me put. This was 2 into t square minus 4. Okay. Proceed with this.
Are you talking about this function? This function?
Yes, ma'am.
Okay. So can we skip that and do this when we come here?
Yes,
Okay,
absolutely.
Okay,
okay,
here I
yes.
have written
Fine.
limits. So let's go and find the derivative. Okay. Okay, y is equal
Ma'am,
to
just
this.
one
So
thing
you have a
additionally.
function.
Just one thing additionally.
Yeah.
While we understand how to calculate derivatives, okay, limits separately, but when we have a function, right? When we are calculating its derivative, in other words, when we are calculating its limit, h tends to 0, what exactly are we doing?
Yeah.
I mean, in terms of a visualization, what is it that we are trying to achieve with all this? When a function is given and a derivative is calculated, limit is calculated, what does it tend, or what do we get in terms of a visual representation is what I'm trying to struggle with. Maybe you might want to take it
Okay.
towards the end of
So
session or in between of session as you find appropriate.
yeah, you have already studied tangents, right? You would have watched about tangents in the
Yes.
lecture, right?
Right.
The tangents are actually associated to the derivatives. The slope of the tangent is nothing but the derivative of the function at that point. And what does the tangent do to the function? Like, what does the tangent like tell about the function or anything?
The instantaneous direction of the slope.
Yeah, one thing is it tells the
So
direction
at a
in which
point,
the
it
curve
is fine. So for example, we have a function and we find the derivative, and at a point when we find it, right, we get the
Yeah.
slope of the tangent, correct?
Yeah.
Right?
Yeah.
But when we have not been given a point and we say that this is the derivative of the function, then what do you mean by derivative of that particular function? So at a point, instantaneous direction is understood. We will come to know the slope, but when we are not trying to find a slope at that particular point, then what do we get with that derivative? What is it?
At that
What is
point,
that
that will
curve
be
in terms to the original function? What is the relation between those two curves?
Okay, so at a point you understand that the derivative is going to give the slope and all that,
Yes,
right?
right, correct.
Yeah. To find at this point what is happening, you actually need to find out f dash of x, right? Only then you can understand what is f dash of a at that point.
Yes, right.
Yeah. So finding derivative is not useless. Like even in studying tangents, you need to find the derivative and then find what is the value of the derivative at that point, so that you get the slope of the curve and all that at that point, and all that, slope of the tangent and all that, right? So you need to understand basic differentiation so that you can find out this value, right? Yeah. So your question was, why are we even differentiating, right?
No, I mean, I'm trying to understand, is there some relation between the two functions? The derivative function also that we have created is also kind of a function, right? So
Yes, the
example,
derivative is
3x
also a
square.
function. Yeah.
3x square will give us 6x as the derivative.
Yeah.
Correct? So is there some relation that we can understand between 3x square and 6x?
At different points of x, you will find different tangents with that 6x versus 3x squared, basically.
Sorry,
Actually,
what?
For different values of x, you will find different values of the tangent, the slope of the tangent. So if you enter, say, 2 versus you enter 0, you will find different slopes. That's the only correlation between them, I think.
Yeah.
Yeah, he is telling
It
right.
gives all possible tangents at everywhere where you want to find.
Yeah.
Yeah, absolutely is correct.
That will be means
That is,
generalized equation.
yeah, that is a general equation, and when
Okay,
you are
so that
touching
will
at a point, there is
okay,
a particular
fine.
point.
So that
This
will
is the
give this that graph 6x will be kind of a slope of the tangents that we will be drawing at 3x square. Is that correct?
At any
Okay.
point, like the general,
I see.
Ma'am,
Okay, fine.
ma'am, excuse
Thank
me,
you.
ma'am. Can
Thank
we
you.
say here to find the linear approximation? We are doing all these things. This is.
Yeah.
Can we say that?
Yes. So the linear approximation, with respect to one variable case, when you do linear approximation, that's going to be the same as a tangent. With respect to tangent, like if you look at it geometrically, then you can tell that it's going to tell the direction in which the curve is moving and all that. The linear approximation is nothing but it's the same as the tangent. So if you have a curve and then you have a tangent, what does it actually mean that this is a tangent to the curve at this point or something? In the week
value,
one lectures,
value of the function at that point, which is having the minimal distance from the tangent point, will be the linear approximation of that tangent from the touching point.
Yeah, it's like basically
It
the
is
linear
like that.
approximation. Is suppose you have say sin x. You know this expansion of sin x, right? That is x minus x cubed by 3 factorial plus x power 5 by 5 factorial. Plus minus something. There is some series expansion for sin x. So this has infinitely many terms, and the powers of x keeps on going. It's not going to stop at some point. So if you want to like plot this, if you want to use it in some data, some kind of a data where you don't need so many powers. Suppose you have very small values of x, and all these are not going to actually give you any values. So you will approximate this to be equal to x or to whatever power you want, right? Then you will put order of x cubed, in the sense that the higher powers, it has some higher powers, but those can be ignored because those are not going to contribute much. Like a linear approximation is good enough for me. You see something like this in data, right? Like you can truncate certain terms, and then take for example a number only. If you have 1.0.134572 or something and it goes on, it's okay even if these values are not given, right? Like these are not going to make much of a difference to the number, right? The hundreds, the 1/100 place, 1/1000th place, all these are not going to give much of information about the point unless we want so much accuracy, right? It's enough if I say it is of the form 1.0 or if I say that it is of the form 101 into 10 power minus 2. This much, if this is enough, then these numbers are not going to make a difference, right? Am I audible?
Yes.
Yes,
Yes,
ma'am.
yes, ma'am.
Yes, yes.
So where the data beyond a point is not needed. So if you have a curve like this, yeah, that's what I was going to tell. If you have a curve like this, and then if I want to linearize this curve, so what am I basically doing is I'm trying to make this curve into a straight line and study that straight lines, because I know studying straight lines is easier. Instead of studying x squared, studying x is much easier, right?
Yes,
Yeah,
Yes,
when
ma'am.
it comes to x and x squared, it's pretty simple. But if I have a complicated function which has a square and cube and all that, it's much easier to study the linear, this degree 1 of it. So this tangent line is just doing that. If I have a tangent to this curve at this point, and if I zoom this portion, if I zoom into this portion, what I'm going to get is that I'll get the curve like this, and then I will have a line here. And then if I still zoom in more, it will be like a straight line. The tangent, the curve and the tangent at the point where they meet, it will be like a linear approximation to that curve.
yes, ma'am. We can say,
So
ma'am, seconds, when seconds move towards the point, it will get equal to the tangent. It will become tangent only,
yeah,
the seconds.
yeah. So you're basically splitting the curve like in terms of the tangents, and you'll be studying these lines instead of studying the curve. That is why this tangent is like useful. And that's basically what linear approximation is. And the tangent is doing the linear approximation. That is why both have the same, like, it's just a notation that's different. When it's the tangent, you write it as y is equal to like as a function. And when it is the linear approximation, you just mention it as LF of x and evaluate at this point and all that. Right?
Reason why we write the equation of the tangent and the linear approximation equation in two different ways. That is, it's the same equation, but we write it in two different ways. Is there any particular reason for that?
No, you write the equation of a tangent as like an actual equation, like y is equal to f of x kind of. Like you
Okay.
write it like that.
Okay.
For the linear approximation, you just use this LF to say that this is the linear approximation of f at x. That's it.
Okay. Okay.
Okay, so let's get back to what we were doing. Yeah, so I was here. I was asking, is it really necessary to understand the derivative of log of a to the base b as, like, is it necessary to study this as a formula?
No,
That
we can apply
log,
the quotient rule after
yeah,
simplifying the log.
exactly. Right, log a to the base b as natural logarithm a by natural logarithm b, and then for this apply quotient rule, because you know how to find the derivative and all that. But I've just written it down here that after you do all this, you will get 1 by x log b, natural log. Okay, so with this, let's quickly solve. I don't think you need help in solving this, right?
Yes, ma'am. Yes, ma'am.
Yeah, because you have sum of functions, find the derivative of each of these functions and add them by the first
Yeah.
rule, and then apply each and every rule to find out the derivative. Okay, yeah. So this is something that uses, okay, tell me, have you been able to solve this problem? This was one of the activity questions, right?
No, ma'am.
Okay, so can someone tell me what we should do here? You're given f at 9, f dash at 0. You want f dash at 9. And you also know that f behaves like this.
Yeah, actually, we can go with simply like differentiation or follow the rules of product. I mean, follow the rule of product rule.
Okay, so how will you do? What is f dash of x plus y? It's going to be f of x into
Yeah,
f of y, the derivative. Yeah, what is this?
that will be equal to f of x into derivative of f of y, then plus
And
f of y into derivative of f of x, and putting the values of x and y, means like at
is
g
this right? Is this right? Like, can someone tell me if this is right?
Yes. Yes, ma'am.
What about
Yes, ma'am.
this? Can you just differentiate f with respect to y?
okay, yeah, dy by dx.
What if y is a function of, yeah, what if y is a function of x? So you'll have a y dash, right? This is that implicit, the chain rule.
Y dash is also.
So you cannot use this, right? Because if you use this, you don't know what y dash is. Y dash at x, basically. You don't know what is y dash.
Function of two variables.
No, f is a
Sorry,
function
didn't
of one
understand
variable.
this. Didn't understand this thing.
F is a function
we
of
can
one variable.
we can assume that both x and y will be the function of something like t or p something, and then differentiate with that respect.
No, see, when in one variable calculus, you always take f as f of.
Ma'am, what is y here? Y is a function of x.
No, you don't know anything about it. It may be a function of x, it may be a constant, it can be anything.
Okay.
Right? Because in one variable calculus, you always take f of x. X is our variable in one variable calculus, right?
In place of x,
so what
here
is y?
x plus y is there.
Yeah. So what is y? You don't know. Y can be some x squared. Y can be some x cubed plus 3. It can be anything. We don't know what y is.
Okay.
Yeah. So when you differentiate, you will have this additional term of y dash of x, which like you don't know the value to evaluate f dash at 9. So how else can we approach?
Ma'am, if y,
Yes.
it will depend on the y. If y is a constant, then it is simpler. If y is a variable and dependent on some x, then the function of x, then it will be different. The both approaches will be different.
Yeah, that's exactly what I'm telling. We don't know what y is.
Yeah, that's
it
right.
may be a constant, it may be a function, so you cannot do this, right? Because
yeah, we can't
you
do
don't
that.
know what this. Yeah. So how else can we do? One thing is, when none of the formulas come to help, go back to the definition.
Okay.
So that is the hint. Go to the definition. So you need to find f dash of 9. What should you do?
9 plus h.
You apply the
limit
definition.
h tends to 0, h plus 9 minus f9 divided by h.
Then?
Okay. Then 9 plus h is not given here. Then what to do? 6. Okay, no.
F9 into
9
FH.
plus h is not. Yeah, it's f of 9 into f of h. And then?
Yeah.
6. F of 9
minus
is 6.
Minus 6.
Okay, we'll keep it as f of 9. Oh, this one you're okay, we'll keep it as f of 9 so that it's easier for us to take it outside.
Yeah.
And then you can take f of 9 outside because that doesn't contain any h, right?
Yeah,
so it's not going to affect the limit.
We'll take common out of that. And it will be f of h minus 1 by h.
What is this?
This is 1.
1, yeah.
Why is it 1?
No, not 1, man. How it is 1?
Yeah, how is it 1?
It is not 1. H. H tends to 0.
It is 4.
How is it 4?
Because it's given.
No. Oh, okay. Yeah, you have used f of 9. You haven't used this, so you have to use it somewhere. But how do you relate it here?
Ma'am, we do
What
the
is
same
f?
thing with f dash of 0 as well and find fh minus 1 by h from that.
So f dash 0 is the definition of this function which is written in rectangle.
No, what is f dash 0? It's f of h minus f of 0 by h, right?
It is h
What
plus
is
0.
f of 0?
F of 0,
Ah.
f dash 0 is f h plus 0.
Yeah, okay. f h plus 0, fine.
Right. Yeah,
Okay,
I mean
you're taking
fh.
f of 0 outside and all that, but then what is f of 0 then?
Yeah, f of 0 is
1.
Why?
How is it 1?
Because over there it's written f of 0 is 1. So in place of f of 0, 1 is there.
Where is it written?
No,
F of 0?
you cannot tell that. You cannot tell that this 1 is equal to f of 0. This is the definition of f dash of 0, and this is something that you have. You don't even know if this is equal to f dash of 0. You want f of 0, but you don't know if this is f of 0. Okay, tell me this. What is f of 9 plus 0?
F of 9.
Another way of writing it from the given thing.
9 into
f of 9 into f of 0.
Yeah. So, what is f of 0?
1. F of 0 should be 1.
That is 1. Now it is 1.
Yeah. Yeah, now it is 1. But there is another way in which you needn't even find out what f of 0 is. Tell me how you can do that. Go back to this step, and from here you tell me how, without finding f of 0, we can find out whatever we have done now.
Sorry, could you just repeat? What do you want?
So here we had to find out what f of 0 is, right? We found out f of 0 is equal to 1. But I'm telling you, without using f of 0, without finding out that f of 0 is equal to 1, how can you solve this?
Ma'am, how is f of 0 equal to 1? Please, can you repeat?
Yeah, f of 9 plus 0 is equal to f of 9, right?
Yes.
But f of x plus y is equal to f of x into f of y, right?
So we want to say for this function only, if f x plus y is equal to fx into fy, then f0 is 1, right?
No, it's already given, no? F of x plus y is equal to f of x into f of y.
We have used that identity for using this, right?
Yes,
Ma'am, we can do it like this, that f of 0 equals to 1. Now we can put f of h minus 1 upon h, that is equal to f dash 0. And we know that f dash 0 is equal to 4. Then we can put it there.
Yeah, I
And
agree to this. But even without finding out f of 0 is equal to 1, can you just do this here?
Ma'am, in the last step, f of h can be written as f of h plus 0 minus f, that 1 can be written as f of 0.
No, that's what I'm telling you should avoid. I'm asking, I don't know what is f of, suppose I'm not even able to find out the value of f of 0, then how can I proceed?
Exactly, that's what I'm telling you. Like f of h could be written as f of 0 plus h minus f of a. That's the thing, right? F of a plus h minus f of a by a plus h minus a.
Yeah.
In that place, in the place of a, we have to write 0. So f of 0 plus h minus f of 0. So in the place of f of 0, it is 1. So
no, again, you're telling what was happening initially. Just because you want f of 0 doesn't mean 1 is equal to f of 0.
okay.
Okay, I think I'll give away the answer. So can I write f of 9 here itself as f of 9 plus 0?
Yes.
And then the next step will be f of 9 into f of 0, right?
Yes.
and then take out f of 9, and then instead of this one I can directly write f of 0 without even calculating what f of 0 is. Now I know that this is equal to f dash of 0, right?
Yes, ma'am. How much? F of 9.
So
Yes.
f of 9, you are writing it as f of 9 plus 0, and then you're using this again, f of 9 into f of 0.
Taking out f9, then f.
Yeah. Right?
How it came? No?
You're taking out f of 9 from the numerator. You'll have f of h minus f of 0.
Yeah, by h.
Yeah. And this limit you know is f dash of 0, right?
Can you please repeat in another page, fresh page?
Can't get it, ma'am. Don't get it. Please.
Shall I remove this portion and rewrite?
Yes.
Yes, ma'am. Yes,
Yeah, remove this one. Yeah.
Okay. So now my thing is, I don't want to find out f of 0. Okay. Without, suppose I cannot even, in this problem, definitely we can find out what f of 0 is.
And basically what we are doing is that the formula which is the equation which is already given here, that function x plus y is equal to fx into fy, that is what we are using it in place of f of 9, isn't it?
Yeah.
Yes.
Okay.
So I'm writing this as limit as h tends to 0, f of 9 plus h minus f of 9 plus 0. Can I do this?
Yes, ma'am. You can do.
Yeah. Then limit as h tends to 0, f of 9 into f of h minus f of 9 into f of 0 by h. Right?
Yes, ma'am.
Can I take out f of 9 now, because there is no h term and it's not involved in the limit?
F of 9 you can take it out.
Into limit as h tends to 0, f of h minus f of 0 by h, right?
Okay.
This is f dash of 0, right? This is the definition of f dash of 0, right?
Yes,
Yes.
ma'am.
Yes, ma'am. Yes.
That's it. So we haven't used the fact that f of 0 is equal to 1, right?
Yes.
So initially, because we just had a 1, that is where we had confusion as to what it will be. But here we haven't even used, we haven't even given the chance for that 1 to appear. We directly ended up in the definition, right?
Yes.
Yeah. So now it's 6 into 4, 24. Right?
Yeah, clear.
Is it clear to everyone?
Yes, sir.
Yes, ma'am.
Yes, ma'am.
Okay, so we'll proceed. Yes. Then, okay, let's do this one. Yeah. So you have f of x is equal to log 5 to the base x, and then you're supposed to find f dash of x. So you have options, and in the options, the answers are in the form log x to the base 5. So we need to do some manipulation. Okay, so how will I find the derivative of this first? I have log 5 to the base x. Change of base root. What should I do?
ln 5
1
by
upon.
ln x.
Yeah.
ln 5 by ln x.
Yeah. Now how will I differentiate this?
1 by 5 by 1 by x.
What is it? What is it?
No. Quotient rule.
Log 5 is a constant.
Quotient rule.
Constant.
Quotient rule.
Yeah. So log 5, natural logarithm of 5, it's a number.
Yeah.
You cannot do 1 by 5, right?
ln
How will you
5
apply
you can
quotient? Sorry. Not
Square.
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 Then log x into what is the derivative of log 5?
0.
Yeah,
0.
because it's a constant. Minus log 5 into what is the derivative of log x?
1 by
x.
Yeah. Okay. So now we have got 1 by x log 5 by log x squared. So in the options, yeah, there is an x in the denominator everywhere. X or x squared or something is there. So somehow we have arrived at an x. And there is a minus sign in 2 of the options. and then there is a log phi, natural logarithm phi in the denominator, but we have it in the numerator. And also we have log phi to the base, x to the base phi. What is log x to the base phi?
Log x by log ln x by ln phi.
So we need to bring it to this form. What should we do? We already have ln x, and then there is an ln phi in the numerator.
You can put ln 5 in the denominator directly, and then whatever it will left, it will do it.
Okay, so I can multiply and divide, right? Like I want in all the functions, in all the options, you have log x to the base phi squared. So I want square of this. So I already have square of the numerator. I want square of the denominator. So let's multiply and divide by ln phi squared, right?
Yeah.
So let's keep this here. 1 by ln x squared is already there. I want ln phi squared. So I'll multiply and divide by it. Right?
Yeah.
Yes.
So I can cancel one of these.
Yes, ma'am.
And then this reduces to log x to the base phi squared, right? That's it.
Yes, ma'am.
Which of the options? Which of the options satisfies? There is a minus sign, so these two are ruled out. X, so this is right. Right? So whenever you have just in terms of log and the base is different, change it to natural logarithm and differentiate, because you know the derivative with respect to natural logarithm. Okay. Yeah, so this is a limit problem. I was asked to discuss this. How will you find out this limit?
Yes.
Okay. For the limit to exist, left limit and right limit should exist, right?
Yes.
When you take left limit, then log t minus 1, this will become negative, right?
Are we
When you
taking
take
left limit first or right limit? I mean,
this is one
right
plus
is...
the right limit.
This is, forget this.
Okay.
Take this. T tends to 1 minus. This will be the left limit, right?
Yes.
In this case, log t minus 1, this is not even defined, right? Log of negative numbers
Yes,
is
ma'am.
not defined.
Yeah.
So, if that is not explicitly mentioned, then we should take it that for whatever values the logarithm is defined, only for that we can talk about the natural logarithm, right?
It means we are looking we'll look for the right derivative, right limit.
Yeah. So in this problem, we will look only at the right limit. Okay, this is not x. This should be t, because the function is in terms of t. So this will be t tends to 1 plus. We need to evaluate this limit alone, right? The right hand limit alone.
Yes,
or let me explicitly mention for t greater than 1, right? For t greater than 1, evaluate this limit. Okay.
But ma'am,
so I need,
ma'am, isn't it a general rule that if to find out the limit t tends to 1, we first find out whether t tends to 1 plus and 1 minus exist or not?
Yes.
So isn't that a general
if
rule?
they exist and they are equal, only then this limit will exist. Okay, so you're telling, okay, let us assume this is given in the question, t greater than 1. Okay.
Okay.
I have just copied this from, this is a part of something. So I did not copy the initial part.
No, I mean to say, ma'am, if such a question comes in the examination, they'll specifically mention, right? I mean, this is the case to be tested for.
Yes.
Yeah. Okay. Thank you, ma'am.
Okay. So when t is greater than 1, you have only right limit, right? T tends to 1 plus of whatever this function you need to find out. So you have a function raised to another function. What comes to help to evaluate limits?
Sorry for interruption. If we are just looking at the question limit t tends to 1, and because I mean t greater than 1 is not given, okay, and we are asked limit t tends to 1. So because left limit does not exist, can we quickly come to the conclusion that this does not exist because left limit does not exist anyway? Right limit.
No, it's not like it does not exist. Log of a negative number is not even defined.
Correct,
that is it.
right.
It's not about it does not exist. This is not even defined. So it's not, it does not even make sense to talk about t
Okay,
less than 1.
fine. Okay.
Yeah. So mathematicians, this is what they assume. When the question is given, it's only for those values of t where all these functions are well defined.
Okay.
So log of t minus 1 will be well defined only when t is greater than 1, right? For negative values, log of a negative value is not even defined. So you cannot even talk about that. So in this case, only those values for which all these functions are defined will exist. That is for t greater than 1. Right? Okay. So let's evaluate this limit. You have a function and then you have power of another function. So what do? You have y is equal to 2 times t squared minus 1 power 1 by natural logarithm of t minus 1. So there was someone who already told me how to find the derivative of that complicated function, right? So we do the same thing here also. How do we do it?
By taking logs.
Yeah, take logarithm on both sides, right? So when you take log on the right hand side, what do you get?
1 by ln t minus 1 into
log of this,
of 2
right?
t square minus 1.
Yeah. So now you want to find out the limit as t tends to 1 of this function. That is, you want to find limit as t tends to 1 plus of y. You want to find out this. So you know that limit, you know that when you take log, you can, like, this is equal to this and all that, right? Like, if you take logarithm, you can do this and all that, right? You would have studied in limits. Log of sequence, basically. Log of an converges to log of a, right?
Yes, ma'am.
Yes, ma'am.
Yeah, what is log a? It's actually limit an. So limit log an is log limit a, right? You can, yeah, because log is a continuous function and all that. So let's just take this for granted. So I'll find the limit of this and then I will get back to y. Okay. So yeah, now how can I find the limit here? Okay, for this we need L'Hospital rule. So let's just quickly recall the L'Hopital's rule. You know L'Hopital's rule, right? When you have an indeterminate form, either 0 by 0 or infinity by infinity. Yes?
Yes, ma'am.
So then what you do when you have 0 by 0 form or infinity by infinity form, given that the derivative of f and g exist, you can differentiate f separately, g separately. Instead of applying any quotient rule, like that's how you generally differentiate, right? When you have f by g, you apply quotient rule. But the L'Hopital's rule says that to evaluate the limit, you differentiate the numerator separately and differentiate the denominator separately. So the condition is assumed in L'Hopital's rule that the derivatives of these functions exist in a small interval containing the point wherever we want to find the limit. And then whatever is that limit, that is the limit of the original function that we started with, right? Yes, everyone knows this, right? So I can proceed.
Yes.
Yes.
Yeah, okay. So now we are trying to evaluate this limit. So we want to find limit of this. How do we do? Limit as t tends to 1 plus, what will be the limit here? T tends to 1 plus, so you'll have, this is 0, log 0 is minus infinity,
Undefined.
and then you have log 0. It's infinity by infinity form, right?
Yes,
It's an
ma'am.
indeterminate form.
Yes.
It's indeterminate form. So if it's indeterminate form, what can you do? Apply the L'Hopital's rule.
Yes.
Right? Differentiate the numerator separately, differentiate the denominator separately. So when I differentiate the numerator, what do I get? Log of something.
That's my
That will be 1 by that something.
2
t square minus 1
minus 1.
and then you need to differentiate that something.
Into 4t.
Right. And when I differentiate the denominator, what do I get?
1 upon t minus 1.
Okay. So now is there some terms that I can cancel out?
T square minus 1 can be written as t minus
T
1
plus
into
1,
t
t
plus
minus
1.
Perfect. So I will have this, right? This I'm cancelling out. There's a t in the numerator. I bring this to the take this to the numerator and all that, and I get this, right?
Yes, ma'am.
Yes,
Yes.
ma'am.
And what is the limit now?
Ma'am, take t common. So 2 by 1 plus 1 by t.
No, limit as t tends to 1. So that's simple, right?
Substitute.
One.
Can we just
2 upon
substitute
2.
and find, ma'am?
Yes, yes, yes. Because both the when you substitute, both are going to exist, right? Numerator and denominator are going to exist, so no problem.
Yes.
So you'll have 2 by 2. That's 1, right? So now I have limit as t tends to 1 plus log y is equal to 1. So what will limit of t tends to 1 plus y be?
E.
Right? Raised to the power e on both sides. Right?
Yes.
So this limit is nothing but
Ma'am, had
so
we
this is
got
how
that,
you.
ma'am, had we got that answer as 2, then it would be e square, is it?
Which one?
That
Here
we
if you
got.
get 2, it will be e squared.
E
Yeah,
square,
whatever
correct?
it is.
Yeah.
So if you get limit of log y is equal to a, then what you actually do to find the limit of y is you raise to the power of e on both sides, because e is a continuous, e power x is a continuous function and all that, you can do this. And again, because e is a continuous function, you will get limit of e power log y is equal to e power a, and e power log y is y.
Okay, ma'am.
So that will be the answer. Yeah. So this is how you use L'Hopital's rule to evaluate limits. Okay. When can I actually apply the L'Hopital's rule? So let's solve this problem. So yeah, what is the first thing for?
Can we use L'Hopital's rule 2 times? Suppose first time it is again not determinate.
Yeah, definitely.
We can use a number of times. Unless it is defined.
You can use it any number of times.
Okay.
The only condition is that only if there is an indeterminate form you can use L'Hopital's rule, right?
Okay.
So every time you get an indeterminate form, you can use L'Hopital's rule. Given that at the next stage, or at least after using it any number of times, the limit is going to exist at some point. That's what the condition says, right? The condition is that this limit should exist. It's not necessary that it should be the first derivative. It can be any number. The order of the derivative can be any number, but this limit should exist at some point.
If this limit exists, then we can find the limit of the original function.
Yes, and you can apply the L'Hopital's rule only under this condition. You can you have an indeterminate form, and then the functions are differentiable, and then at some stage this limit is going to exist. Then only you can apply L'Hopital's rule, and after applying L'Hopital's rule, you can tell that this limit is actually going to be equal to the limit that we ended with.
Ma'am, and the number of derivatives. Ma'am, the number of derivatives that we find should be equal for the numerator and denominator, right? It can't be like
yes. You cannot randomly differentiate numerator, and you need to differentiate it every time, both numerator and denominator.
Excuse me, ma'am.
Yes.
Ma'am, can you scroll up?
Okay, we'll do one at a time. We'll do the scroll. Whatever the person who has asked me to scroll up, we'll finish.
Where you solve the question. Where you solve the question.
Oh, that one. This
yes,
one.
Ma'am. In this, you used L'Hopital rule. So in this, we derivate f dash of x, and then we derivate g dash of x. So if we are just derivating the function, like if you are not finding the limit, and we're just derivating the function, we'll not solve it like this, right? We'll use the quotient rule, right? When it comes to differentiating ln of 2t square minus 1 upon ln of t minus 1. You won't be differentiating the same way that you did in this procedure, right? You'll be doing the
that's exactly what I told you. So here you're not differentiating f by g. You're differentiating the numerator separately, the denominator separately. Right?
Yes, ma'am. Thank you.
Yeah. Okay. So there was another person
Ma'am,
asking
actually,
about.
again,
Yes,
ma'am,
ma'am.
this question, what he has just asked, we are not applying the quotient rule over here.
No, we are not doing f by g derivative. We are not
Correct,
doing
right?
this.
Yeah, it's separately. Yeah, fine, okay.
Yeah, you're doing f dash by g dash. Yes.
And then
Yeah,
applying
there
the
was.
limits. Yeah, fine.
Yeah.
And that is defined by it being indeterminate, right, ma'am? Whether we
No,
apply.
if it's indeterminate, that is the first thing that you need to check. If it is indeterminate, that is when you start thinking whether you can apply the L'Hopital's rule.
Ma'am, what do you mean by except possibly at A? If you can just specify.
Okay, so conceptually, the derivative, when you want to define the derivative of a function, okay, for the limit to exist, is it necessary that the function should be defined at the point?
No.
No.
For the limit to exist.
No.
That's why it is written like this. So in the next step, what are we doing? We are finding limit as x tends to a f dash of x by g dash of x. So for limit f dash of x to exist, is it necessary that f dash of a is defined? No, right?
F dash of A or F dash F A?
F A.
F A, na ma'am.
No. I am talking about f dash, existence of f dash. Except possibility at a. Yeah. No, forget this. Forget f dash or anything. If you want limit of f of x to exist, is it necessary that the function should be defined at at a?
No.
No.
For the limit of f dash of x to exist, is it necessary for the f dash to be defined at a?
No.
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 No, right? Instead of f, I am just writing f dash. F dash is also another function. That's it. That's why it is written except possibly at a. It may be defined, but it doesn't matter, because when I'm talking about limiting process, I'm not talking about the value of the function at that point.
Okay.
Yes,
Got it.
Okay. So there was one
Actually,
person trying to ask a doubt. I don't know if that person's
we are
doubt
at
is clear.
such a stage. We are at such a stage. These kind of nitty-gritties are not making sense to us. We are still struggling with the major concept of the question.
Okay.
Yes,
Yeah,
ma'am.
I understand, because the aim of this course is not to actually teach you the basic concepts of these, right? It's like to prepare you for data science, right? It's not a mathematics course, like it's not a BSc mathematics or something. So if we try and sit and explain all this to you, like these are something we studied for an entire semester when I did my BSc in mathematics. Just limits, derivatives, and all that it's like the analysis of functions. So that's one entire course in one semester for me. So that's the difference, right? I was getting a BSc in mathematics. Here we are studying this course.
How we will digest it, ma'am? How we will digest it?
Yeah, that's why we are just stressing at those points which are needed. That's why I did not even talk about this, right?
And if I
But
I'm
anyway,
sorry,
you know that for the function, for the limit to exist.
I'm digressing from the topic. The functions is the topic for your PhD also, right? Functional analysis.
That's completely different.
Okay.
Another doubt in that question, ma'am.
Functional analysis is different.
Okay.
Ma'am, can you school, ma'am?
Which one?
On the same question. Yeah.
This one.
Ma'am, if we assume that, like if it is ln 2t square minus 1, and this is in the denominator, like if we have a numerator above x, like it is x by ln of 2t square minus 1, and in the denominator it is ln t square t minus 1. Like if we have in the numerator itself p by q form.
Okay. In the numerator itself, you have p by q.
P by q form,
okay.
and then there's a denominator. Then can we put like limit of t, like in this p by q form, can we use f dash of x and g dash of x, or we have to use the quotient rule?
So what does L'Hopital's rule say? You need to differentiate the numerator separately, differentiate the denominator separately.
Yeah.
Right?
But if we can
So for
apply
this,
like
you will be using quotient rule.
okay, but ma'am, we can wouldn't it be like limit of for p by q? Wouldn't it be limit of t tending to 1? Then we can differentiate by f of f dash of x and like p dash of x and q dash of x like that.
Yeah, you can apply the L'Hopital's rule for the numerator separately, but that's going to affect the function, right? Like f p by q by r. So someone had asked me, right, can I differentiate the numerator n times and the denominator n plus 1 times? That doesn't work, right? You need to differentiate. If you differentiate the numerator once, you need to differentiate the denominator once. So if you try and apply the L'Hopital's rule for the numerator to evaluate the limit, that's not going to help, right? Okay, are you asking this? I have p by q by r, and then I want to find the limit of this. So
Yes,
I
ma'am.
tell that this is equal to limit of numerator and then limit of denominator. And then for this, L'Hopital's rule, is it?
Yeah.
Yeah, you can do that. You can do this. See, the thing is very simple. However complicated function I give, whatever be the function, like whatever it is, how many ever numerators it has, how many ever denominator, or whatever it has, the thing is this: you write it in the form f of x by g of x. That is limit f of x by g of x. So this f can itself be quotients, can itself be products, it can be anything. Similarly, the g itself can be anything. If the numerator is going to be some p by q, that p by q is also a function, right? P is a function, q is a function. So p by q is a function, right?
Yes, ma'am.
So that can be taken as f. And the denominator, say it has something power, something power, something. That is again a function. So that can be taken as g. So write it in this form. And then how will you apply L'Hopital's rule for this? If you get indeterminate limit. Suppose you're not getting indeterminate limit. Suppose numerator is some infinity, denominator is something else. Then you're done, right?
Yeah. You can't apply L'Hopital, right?
If the denominator is a number, you're done. Numerator is infinity, then the limit does not exist. Done. You cannot apply L'Hopital's rule. Now, if the denominator is infinity, numerator is some number, you're done. The limit is going to be equal to 0. Yes. So, however complicated function you get, what you have to do is try to evaluate the limit of f of x and limit of g of x. Now, suppose you have to evaluate limit of f of x. Now, f of x itself is a quotient, right? Say p by q. So, there you can do anything. Ultimately, you want to evaluate limit of f of x. So, if f of x is going to be p by q, is it low?
No, it was actually
now
not continuous.
Oh,
no,
okay.
Now it is. Now it is. Now it is. You can continue. You can continue.
Okay. So let me write it down more clearly.
You can insert a page right in between. And yeah, ma'am.
Can we do that here?
Yes, ma'am. Subhajit sir was doing that previous.
Oh no. He was using it in a
PDF,
different.
so in H
yeah,
you
here
can't
I'm
do that.
writing on a I'm writing on a PDF. Okay. So to apply L'Hopital's rule, I need to evaluate this limit. So I'm going to apply L'Hopital's rule and evaluate this limit, where my f of x is p of x by q of x. Okay. Let's keep g of x normal. Means simple. Okay. So if you know the cases, when can you apply L'Hopital's rule? When you get infinity by infinity form or 0 by 0 form or something, some indeterminate form. And then what will you do? You will do limit of f dash of x by g dash of x. Say this limit exists. Okay. And then you will say that the limit is going to be equal to L. Okay. So what are you doing here? What is f dash of x? What will you do?
Quotient rule of p by x, p by q.
Yeah, you're not going to do p dash by q dash. That's not what you should do. You should find the derivative of f. And the derivative of f is the derivative of this. So you have to apply quotient rule. Fine? Okay. So now what are you doing? To get that this is indeterminate form, what should you do? You should find out limit of f of x, right? and limit of g of x naturally, right?
Yes, ma'am.
Now what is limit of f of x? Limit of p of x by q of x, right?
Yeah.
Can I apply L'Hospital rule here, the L'Hopital's rule here?
If it is indeterminate, yes, ma'am.
Yeah.
Yeah,
Yes.
exactly. So it doesn't matter. So you see what I'm trying to explain? Like you have f of x by g of x. Can I apply L'Hospital rule to f of x and all that? Yes, because f of x is a function. And if I want to find out limit of f of x, I want to find the limit. That's it. I can do anything to find the limit, right? If I'm going to get indeterminate form, I will proceed with L'Hospital here. And I will go till I get the limit as infinity or 0, so that this becomes an indeterminate form, right?
Okay.
But the thing is, if you want to proceed and go and do this L'Hospital rule, this limit is going to be some number, right?
Yeah.
Yeah, so there the procedure stops, right? Because if that's going to be a number, if the numerator will be a number, so irrespective of what the limit of the denominator is, you needn't even apply L'Hospital rule here, right?
Yeah. When it is x or okay, got it.
Yeah. So you'll get L by infinity. So this is just going to be 0. You needn't even apply L'Hospital.
Yeah.
So the thing is this. What I want to tell is this. You want to find the limit of something, you find it by all means. That's it.
But any sort of question is going to be asked in this form in our graded assignment, or will there be any question similar to this pattern in this task?
No, I don't remember the graded assignment, but
No,
I told this because you asked me this. Otherwise, I wouldn't have brought. Yeah.
Thank you, ma'am. Thank you.
Yeah. Okay. So the aim is to find the limit. How you find it, it's all up to you. Yes.
Ma'am, one conclusion when we evaluated the ln y is equal to.
Can you talk a little loudly? I'm not able to hear you clearly.
Am I audible, ma'am?
Yes, perfect.
Yeah. In the same also, when we limit ln y is equal to e to the power a, I got some confused here also. Yeah. Please once again, because the speaker was gone off by that time.
Okay.
Just,
so yeah, you want to find out limit of y. Okay.
Yeah,
but since it's a complicated
ln y is equal to 1, it is okay.
Yeah. So you you end up finding out limit of ln y, but you want to go back to limit of y, right?
Yeah.
So for that you do, so this is equal to 1 for us in this problem. So you raise, I want to eliminate log. So naturally I will raise both sides to the power e. Like if I have x is equal to y, then e power x is equal to e power y, right?
Yeah, it is correct. Yes.
Yeah, so I do this. And then because e is a continuous function, what you can do is this will be equal to limit of e power log y. This is going to be equal to limit of e power log y.
Okay, we can take limit out also.
Yeah. And then what is this? This is y, right? E power log. Yeah. So
then y is equal to e to the power 1.
So you have found out the limit of y, and the e on the right hand side is going to be there. Yeah, it's going to be e power 1, so that will be e.
Then how this e to the power a came, man? Okay, this is example here.
Oh no. This I was telling if suppose it is equal to a. Yeah.
Got it.
So someone had asked me what if it was 2. So I just took.
Thank you.
Yeah. Okay, so let's quickly solve this one. So the question is not to find the limit. The question is, where can you apply L'Hopital's rule? Okay, let's start with option 4. Can you apply L'Hopital's rule for option 4?
No, ma'am.
No, ma'am.
No.
Why not?
No.
The numerator.
It's not even in the indeterminate form, right?
Yes.
No. You needn't even go to differentiation. It's not even in the indeterminate form. You have 1 by infinity, which is 0. You know it is 0. Like it's not infinity by infinity or 0 by 0.
Correct.
No, it is 1
so
by 0, right?
The indeterminate. Sorry, yeah, 1 by 0.
1 by 0.
Yeah, 1 by
so
0
it goes to
The limit does not exist. Yeah, it is actually, yeah. If no, it's not indeterminate. Indeterminate means it is either in the form infinity by infinity or 0 by 0 or 1 power infinity. All these are indeterminate forms. 1 by 0 or 1 by infinity, these are not indeterminate forms.
So because
Right?
it is not indeterminate, hence it is not falling in the category of L'Hopital, right?
Yeah, correct.
Yeah. It's
Okay,
not,
fine.
you can, what is the first thing that you need to apply? Think about L'Hopital's rule.
You can apply in
Indeterminate
option
form. So
1
that
and
itself
option
is
2.
not.
So 1 upon 0 is not indeterminate. Okay.
These are, there are some 6 or 7 indeterminate forms, of which in the course you will be worried only about this. Okay. What about option 3? No, the limit of the denominator is a finite number, right?
Yeah.
And the numerator is
Also finite number, so we cannot apply here.
Yeah, it is not.
Irrespective of what the limit of the numerator is, limit of the denominator is finite. So you cannot apply L'Hopital's rule because it's not going to be indeterminate form. Okay. What about option 2?
1 and 2 will apply.
Okay. Option 2, why?
Sin square x is 0. 1 minus cos 0
So
is
you have 0 by
0 form.
0 form. And then what do you do?
Option 1. Then
You differentiate numerator, you
And we can
differentiate
apply.
Cos 2x equals to 2 sin square x.
minus sin 2x, and then
Means
there
we
is a
can
minus
also do cos 2x equal to cos 2x formula for sin square x. Cos 2x equal to 1 minus 2 sin square x, like that. And we can do.
Yeah, you can do that. But again, it's the aim of this question is not to find the limit. Where can you apply L'Hopital's rule? That is the thing.
Yeah.
So I cancel this out. Now, what is the limit?
Again it is 0, ma'am. Again we have to. Again it is again.
No, it's 0 by 0, right?
Again
limit as x tends to
Yeah,
0.
again we have to apply L'Hopital.
2 sin x cos x.
What is it?
Then sin 2x is 2 sin x cos x. We can write it like it.
Yes. It's fine. But I wanted to keep it this way so that I can tell you that you can apply L'Hopital's rule again. You can definitely write 2 sin x cos x as sin 2x and then cancel and all that. That's fine. But I'm just telling you, like you can go another step also.
Sorry, I missed this part. 0 by 0, then how come 2 sin x cos x upon 2 sin 2x is coming?
Differentiation.
You're differentiating the numerator, differentiating the denominator.
F dash x upon g dash x.
Sin squared x, derivative of sin squared x is 2 sin x
minus
into
sin
cos
2x by into 2.
I'm using product rule. Differentiate sin square x.
Yeah, so basically you can do this. At this step, you can say the numerator is sin 2x. Sorry. The numerator is sin 2x, and then the denominator, you can just cancel and then you can find the limit. But I'm telling you that you can take it another step also. Again, if you don't want to simplify, then again you'll get 0 by 0 form. And then again, for the numerator, you have to do product rule. Denominator, you have to differentiate it. Yeah. So that's going to be sin squared minus sin squared x plus cos squared x by cos 2x into 2. Right?
Yes.
Now when I apply the limit, I will get a number. 1 by 2.
1 by 2 will be 1. Sin x will be 0 and cos x will be 1. Correct.
Yeah.
Miss, and
So
can
this is
it
the
be
value of the
possible
limit.
that
But the thing is, can you apply L'Hopital? Yeah, what is it? Can it be possible that?
that means without using the formula, means before we have done 2 sin x cos x upon 2 sin 2x, then means without doing double differentiation, it can be possible that we get different answer.
Yes. In fact, you can do it here itself, no? Sin squared x is something, no? 1 minus cos 2x or no. I think it will be sine squared x is
Yeah. Cos
1
2x
minus
equal
cos
to
square
1.
x.
Yeah, 1 minus cos squared
1
x,
minus
yeah.
cos
And
2x
then
by 2.
cos squared x in terms of cos 2x you can write.
No. Means I am asking that is it possible that we different answers can be possible for different ways, or answer will be the same?
Yeah, however you find, the limit is going to be the same. Because if the limit exists, it is unique. You can find the limit. If the question is find the limit, you can find it in any way you find it comfortable. There is no compulsion that you have to do this way only, unless it's mentioned. If they mention use L'Hopital's rule to find the limit, then maybe you find a 0 by 0 and then find the limit and all that. But otherwise, I don't think that is going to be mentioned to you. Find the limit. You have the freedom of finding the limit in whichever way you want it. Fine?
All right.
Yeah. So you can apply the L'Hopital's rule for option 2. Similarly, can you do it for option 1?
Yeah.
Yes.
Okay. In the activity question, there was this, right? Or in solve with us, I don't know. In one of the things, the other was there, right? Like the same option 1 with extends to infinity. I think it was in the activity question.
Both are there actually. Solve with us has extends to 0 and the activity has extends to infinity. Both. So you get confused in both actually.
Well, here also we can apply. Here also we can apply, right?
No, you tell me if we can apply or not.
Well, it is getting into infinity. So it is infinity by infinity. We can apply.
Okay, then what will you do? You differentiate the numerator.
Yes.
Differentiate the denominator.
1 plus cos x. Yes.
Now as x tends to infinity, what is the limit of this function?
Ma'am, limit does not exist here, ma'am.
Exactly. So you cannot apply the L'Hopital's rule here. Because as x tends to infinity, what is this? You don't know, right? You just know that cos x is going to be between -1 and 1 like this. It's not going to be a particular number as x goes to infinity. So this limit does not exist as x tends to infinity. So you cannot apply the L'Hopital's rule here. And you cannot proceed further, right? You don't have an indeterminate form here. So you cannot proceed further with L'Hopital's rule.
Okay. Okay, ma'am. Got it.
Yeah.
Then what to do, ma'am?
No, you cannot apply the L'Hopital's rule here. That's it. That's all I'm telling. If you want to evaluate the limit, tell me, how will you evaluate the limit?
How to evaluate the limit?
We can apply
L'Hopital
quotient
is
rule.
not applicable here.
Yeah, L'Hopital's rule is not applicable, but if I ask you to evaluate the limit, you have to evaluate. You cannot tell that L'Hopital's rule is not applicable, so I won't evaluate. Yeah.
Apply, ma'am.
We can apply
What is
quotient
it?
rule.
Quotient rule.
No, why will you differentiate? I'm asking you to find the limit. Why will you differentiate?
Divide by
I want
x.
you to find the limit of this function.
Then we can divide by x. We can divide by x.
Okay, then
we will change the limit. Put h.
Then I need this, right? I need limit as x tends to infinity sine x by x. If I know what is this limit, then I know the answer to this, right?
Yeah.
Which one?
What is this?
But this is what we don't know.
This is 1.
Does not
Sin
exist.
x upon x is 1.
One.
No, that is when
No.
x tends to
When
0.
x tends to
This is the
0.
next.
When
That is
it, let us change the limit from h tends to 0 and x is equal to 1 by h. Put in that form, then we can do that.
No, but you know this, right? Sin x is bounded.
Yeah.
So whatever happens,
0.
wherever we look at sin x, even at infinity, it's going to be like this. It's going to be a curve like this, right? But there is an x in the denominator that's going to pull this limit to 0, right? Because the numerator is bounded.
Okay.
Oh,
That's not. So I can write it like this.
So will it be
Like,
0, ma'am?
okay. Yeah, it will be 0 because as x goes to infinity, the denominator term is going to take this entire function to 0. Because the numerator is bounded, the denominator is what is actually playing this function. Right?
Okay. So then when in case of 1 by 1 plus cos x also, now cos x is also bounded function.
Yeah, same.
And so now we got a value, so now we can apply L'Hopital rule.
No, why will you apply L'Hopital's rule? You got a value, that's all.
Okay.
1 by 1 plus 2.
Yeah,
this is the answer.
It means
No,
sin x
this
by
is if you are asked to evaluate. Like, but can you apply L'Hopital's rule? No.
No.
Because of this.
It means the limit x tends to infinity sin x by x is 0.
Limit x, yes. Limit x tends to infinity, sin x by x is 0.
We can use it in other cases also as an identity also.
Yeah, but why should you use it as an identity when you actually know to evaluate this? Identities is something which is like, it's difficult to prove or it's very basic. Like that is, now you know how to prove it. When someone asks you, you know how you can prove this limit is equal to 0, right?
Then we can say that sin x is a bounded function, so
yeah,
only x is then
yeah. Okay.
Thank you.
Yeah. So is there something that you want to discuss about tangents? It's pretty simple, right? Straightforward. Equation of the tangent
Tangent and
linear approximation.
Linear approximation. These two things should be clarified to the questions.
What is it? You want me to discuss this in detail? Or we'll go to questions directly?
Linear approximation.
So yeah, just like how I told you initially, what does the tangent do? The tangent is actually, as you zoom in the curve, it's actually going to give a linear approximation to the curve. So you can split the curve into pieces, like pieces of lines and study. That is what the tangent is doing. So that is the linear approximation. You are giving a curve a linear approximation. That is an approximation in terms of lines, small pieces of lines. The thing is, however I draw a line, it's not going to approximate this curve, right? Completely, not approximate. It's not going to be this curve. Because if there is a line that is going to be equal to this curve, then this curve would have actually been a line, right? That's why it's called an approximation. So you're trying to approximate this curve using small pieces of lines. That is what you're doing in linear approximation. And that is the job done by the tangent. So when you want to find the linear approximation of a function at a point, what you do is this. This is nothing but the equation of the tangent, right?
The value of the equation of the tangent at a particular point is the linear approximation at that point.
Yeah. See, for example, I have a curve like this. Okay. Now, if I want to approximate this curve by linear approximation, means you're approximating the curve by a line, right? Yes or no? Linear means by a line, right? By a polynomial of degree 1, which is going to give you a line. So suppose I want to approximate this curve at this point by a line, that's going to be some line, right?
Yes.
Okay.
It will be this line. If I want to approximate with respect to this point, it will be the tangent at that point. So it's going to be this line, right?
Yes.
Now, if I want to find the value of the function at this point, I mean in the x-axis, at this point, using the linear approximation at this point, what I'm actually getting is this value, right? What I have done is, I have approximated this curve by a line which best approximates at this point. That is why linear approximation. What is this A?
Geometrically, this is the meaning of the linear approximation.
Yeah. Why is it A here and why is it X here? That's because this A is actually going to give me this line, and this X can be any point on the thing, on the real line, and at whatever point I want, instead of finding out f of A, I am actually finding out the value of the, like, I'm finding out the value of the, what is the value of, okay, on this line, what is the functional value, right? Okay, tell me this. This is my x-axis. I have a curve. Okay, let's make the curve beautiful. Now, if I want to find the tangent, this is say 1, this is say 2. If I want to find the tangent at 1, what will I do?
We will draw a
I'll
tangent
go to this point and then,
passing from 1 and 2.
No. You will draw a tangent at the point 1 comma f of 1, right?
Yes.
If I want to find the tangent at 2, what will I do? I'll draw a tangent
2,
here.
2 comma f2.
So if I am going to draw a tangent at every small point, 1.001, 1.002, if I keep drawing tangents at each of these points, I'm going to like approximate this curve by lines, right?
Yes.
So if I have this curve, what I'm doing is I'm drawing lines like this along the curve, right? Yes or no? This is when I draw a tangent at each point. I'm going to somehow, if I make the points closer and closer, I'm going to somehow get a line kind of structure which I can study and understand the function, right? Now what I'm doing is in linear approximation is, so I have this function and I have this point. Okay, so I'm drawing the linear approximation to this curve at this point. What will that be? It will be the tangent, right? That's the best linear approximation possible, right? Okay, let's assume this is touching.
Then for the linear approximation, at every value of x, we will get different type of linear approximation.
No. Yeah, it is correct. What you told is correct. But what are we actually doing?
What I mean,
What I
mean to say, ma'am, some questions are there. The linear approximation for a company, for a chemical composition. Then the curve is there, and we are getting equation of the tangent at a particular point. But when we change the value of the point, then the every approximation will be different. Then it will be of no utility, I think so.
No. That's what I'm going to tell you. So now I'm telling you to find the linear approximation at 1. So that is this line. Agreed?
Okay, yes, agreed.
Now, if I ask you to find the value using the linear approximation at, okay, so linear approximation at 1, find the value of function at 2 using the linear approximation at 1, what will the value be? Will it be this or this?
No, on the straight line, on the tangent line.
Exactly. So, no, not on the tangent line. It will be on this line. It's not, we are not talking about the tangent at 2. We are talking about the value.
Yeah.
So what
value, value of the value of
you're doing the linear approximation for a point.
Yeah,
Got it.
But what I mean to say, ma'am, this is a tangent at a particular point. But when you take another tangent, another point, then all the approximations will be different. Then how it is physically used in the real life?
No, that's what. No, you are given.
Suppose I want to make some prediction for that. Then a tangent I will be of no use because of on the every point there will be different tangent.
Yes, I agree. I completely agree with that. But the thing is, how do you want to approximate? That's exactly what I was telling with respect to numbers. No, if I say first 2 decimal digits are enough, then that is my approximation. If I say first 100 decimal are needed, then that is how accurate you want the data to be. So it depends on how you want to approximate it. So just like how we saw this, if I take the linear approximation at 1 and then find the value of the function at 2, like approximately on this linear approximation, that's going
It means this is our choice.
to make a lot of difference here,
At
right?
what point? At what
Yeah,
point
it's
we
your
want
choice.
to take the it is our choice to take the tangent. At which point we want to take the tangent and use at a linear approximation, right? Am I right?
Yes, yes, you are right.
Oh, got it.
Now, if I want to find the linear approximation of this curve at 2, that's going to be like this, right? That is going to be the tangent at 2, right?
Yeah.
Now, if I want to find the value of the function at 1 using linear approximation at 2, that's going to be this value, right?
Yeah, it is totally different from the earlier, right?
Yeah, exactly. So it depends on what you want to do. With respect to data also, it's the same. It depends on what you want to do.
Just to clarify, so it's basically when we are using the linear approximation for another point, say on the tangent, then we just substitute the value of x for the point that we are trying to find the linear approximation for. For this, now what I'm trying to say is that the linear approximation has this equation. F of a
This equation,
plus,
yeah.
yes, prime a.
So this is the linear approximation at the point A. At the point A, this is the tangent, right?
Exactly. Yeah. Now, if I want to find for f of say p, then I'm sorry, x for x equal to p, then I just substitute the value p at x in the same. Yes. Okay. Understood.
So that's what I was telling here. So you have 1 and 2, 1 and 2, and then suppose you take the linear approximation at 2 and find the value of the function at 1. That's going to be this. That's not going to give you this.
Yes, ma'am, the a is 2 and the x is 1, correct?
A is 2, yes. You're approximating the curve by a straight line at 2. So A will be 2. And what is the value of the function that you need to find out? Where should you find the value of the function? At 1. So x will be 1. So in linear approximation, what you're doing is, whatever is the point where you're finding the linear approximation A, you take the tangent at that point and then you do things. Instead of considering this curve, now you just consider this line and then work on this line. It may be a bad approximation, but that's what you chose, right?
Got it, thank you.
Yeah. So all these are pretty simple problems, right? Like find the equation of the tangent and all that. You just plug in values here. Find the derivative at the point they're asking and all that. So quickly tell me how will...
Yes, ma'am, I have a question regarding continuity and differentiability.
What is it about?
Continuity and differentiability. If a curve is continuous at all the points, does it mean that it's differentiable at all the points? Or
no.
Is it like, yes. And how can we know, looking at the curve, whether it's differentiable or not? Means if we don't have the equation.
So whenever there is a sharp edge, yes, what is actually happening? So how will the tangent? So this is the curve of mod x, right?
Right.
So what will, when you try to find the tangent at all these points, what is happening? It will be like along this line, right? Yes. Along this line. Okay. What is the tangent of a straight line?
It's
the same extent.
The line itself.
It's itself, right? Because when you find the derivative, that's going to be a constant, right?
Constant, yeah.
Okay. So when I have this, the tangent along all these points is going to be this, along this straight line, right? And similarly, along all these points, it's going to be along this straight line. What happens at this point?
Drastic changes is being happening.
Yeah, the tangent is shifting from this to this suddenly, like from this to this.
There is
right?
no...
Like, yeah, there is a sudden, it's coming like this and then suddenly it has to turn. Yeah, so that's why.
So it means that it's not differentiable at this point.
Yeah, Exactly, because the left limit and the right limit will not be equal of that f of x plus h, whatever, that value.
Okay, but if it's
So
coming
whenever
from the left hand side and right hand side, it's a straight line, then in that case, what would be the case?
What is
Like,
it? Along
like it's like the diagram that you have drawn. If it's a curve from the left hand side and from the right, it's the straight line, and the intersection point is the origin. Means till the origin, it's the curve.
So here the tangent is going to smoothly change its.
Yeah, this is okay, but suppose in the diagram, the left hand side, the curve is still 0, 0, and from there it's a straight line.
Do you mean like this, something like this?
Right, ma'am, right, ma'am.
So here again, from here it is coming smoothly. But then again at this point there is a sharp turn, right? So here there is going to be like, so here there is a sharp turn where the tangent will have to turn immediately. So this is one way of looking at the curve and telling. But if the function differentiability implies continuity, right?
Yes.
So if it is not continuous, it cannot be differentiable, right?
So
because if it was differentiable, it would have been continuous.
So both statements are correct, right?
X is continuous, ma'am.
Yes.
Yes, ma'am.
Is my voice breaking?
No, it's fine, ma'am. It's okay. We are able to
No,
listen
ma'am.
to you.
No.
Okay.
It's okay.
So when I take the step function, at this point, will the tangent exist?
When it is continuous, it may not be differentiable.
Ma'am,
like this.
Ma'am, we missed this question. He's saying that mod x is a continuous function, then why it is not differentiable at all the point? That question was missed out in other discussion. Yes. Like we are saying now that if the function is differentiable, then it is continuous. In the same way, if it is so mod x is a continuous function, then why it is not differentiable at this sharp corner?
No, that's what I explained now, right? If it's differentiable, then it is continuous. But if it is continuous, it need not be differentiable. So this is a continuous function which is not differentiable at this point. Just because I explained now, no, the tangent will have a sudden change of,
Okay.
That's what differentiability implies continuity.
But how?
Ma'am, it is not continuous.
Which is not continuous.
No, ma'am.
This is continuous, no?
Ma'am, at x equals to 0,
Ma'am, my question was how to know whether it's differentiable or not.
This is not differentiable at 0 because there is a sharp turn.
Okay. Means wherever we find the sharp edges and the equation is not given, we should assume that it's not differentiable.
Yeah, you needn't assume. It is not, no, because the tangent is going to come along this and then suddenly it's changing here. So there is a sudden change here.
Okay.
Yeah. So someone was telling this is not continuous. Why is it not continuous? I did not take my pen out at all, right? I'm able to draw it continuously.
From the basic definition of differentiation, you can say that tangent is more concerned about the nearby values of the.
Exactly.
Right, because at the sharp edges, we cannot predict the nearby points. So that is why it is not differentiable. Am I right? No.
Yeah, so when at the sharp points, what is happening? When you compute the left-hand derivative, h tends to 0 plus and h tends to 0 minus, left-hand and right-hand derivative, it's going to behave differently in both the places. Yeah.
And
so
the differentiability is more concerned about the nearby points.
Yeah, so because the left-hand and right-hand limits are not going to coincide, this limit is not going to exist. F of x plus h minus f of. So this is the derivative, right?
Okay, thank you. Got it. Yeah. Triple meaning is very much required to use that.
Okay, so
differentiability is associated to derivation, right? I mean, it's associated with that, right? When you say a function is differentiable, it means basically we can differentiate it. I mean, in the sense, find derivative f dash x we can find.
Yes.
I think I'm missing out the basics. That's why I keep asking these.
Yeah, no problem. No doubt is silly. You can ask any doubts.
Very much clear, ma'am. Very much clear. Now it is very much clear. Yes.
Yes, ma'am.
Okay. Yeah.
We can now hit the questions.
Ma'am, can we say that mod x is it exceptional case where it is
continuous but not differentiable.
No, you have many continuous functions which are not differentiable. It's not necessarily just mod x.
If it is
That's the
differentiable,
easiest
it will
example.
be yes, ma'am. If it is differentiable, then it will be definitely continuous. But if it is continuous, we can't say that it will be differentiable also. Like not vice versa.
Yes.
We can say that, right?
Yeah. Y is equal to x is continuous and differentiable. But y is equal to mod x is continuous, not differentiable.
Yes, ma'am. Got it now.
Yeah.
Ma'am, what is the answer of this A question? I lost my connection between.
No, we did not even discuss the question yet.
Okay, okay.
Yeah, so you tell me, how do we do this? What is the equation of
8x?
What is it?
Just differentiate and put the values in that one. That's all.
Ma'am, it's
Yeah.
16 x minus 1.
Which one? Can you repeat?
Ma'am, 16, then bracket x minus 1.
Where? Which one? This problem? The one that I'm writing?
Not properly audible.
Yes, ma'am.
She's trying to answer A only, ma'am.
Okay, y is equal to f of x into f dash of x is going to be 8x into x minus like at whatever point you want to find
X minus 2, right?
X minus 2 here.
Yeah. So in fact, everything will become 2, right? Like it will be f dash of 2.
This is f dash 2.
And f of 2. Yeah, it will basically be.
We have to take.
Okay, what should you find? What will be the equation of the tangent of a parabola? Okay, at the point this. So x is equal to 2 is given. So y is equal to f of 2 plus f dash of 2 into x minus 2.
Yeah, this is the
That's it, right?
Yeah.
Yeah. Okay, how will you do? What is it?
16 plus 16 x minus 2.
Y is 16.
No, y is not 16. F of 2 is 16.
16 plus 16 into x minus 2. This is the equation.
16 into x minus 2. Yeah.
This is the
8x, 8 into 2, 16. Yeah.
Yeah.
So this will be 16 into 1 plus x minus 2. So this is 16 into x minus 2. Okay, how will you do B?
Find the equation of a line passing through 5, 8 and 1, 0.
The line passes through the.
You find the equation of line passing through 5, 8 and 1, 0.
Is it if a line which passes through the point 5, 8 is the tangent to the curve at the point? Oh, okay. Yeah. Then find the value of.
From that we can find out f dash 1.
Yeah, just the slope of the line joining 5, 8 and 1, 0, and that is going to be equal to f dash at 1, right?
Yes, ma'am.
Ma'am, here I got a question like, this one is curve is upwards or downwards kind of thing. Means, shall we take plus? I'll use the minus value.
For which one?
Ma'am, there is no need of finding the equation in this question, I think.
Okay. How can you do? There are multiple ways in which you can do. Yeah, tell me how will you do?
Ma'am, there are 2 points given 5, 8 and 1, 0. Then we can directly find the slope.
Yeah. Yeah, you needn't find the equation. Yeah, just find the slope by 2-point slope formula. Or if you just want to go by the theory, then the tangent to the curve at the point 1 is going to be y is equal to f of 1 plus f dash of 1 into x minus 1. And then you know that this function passes through 5, 8. So that's going to be 8 is equal to f of 1 plus f dash of 1 into 5 minus 1. So, and f of 1 is 0, no? Because tangent at the point 1 means this is 1, f of 1. So f of 1 is 0, we can ignore this. So f dash of 1 is going to be 8 by 4, that is
2.
But the easiest way is what you told. The slope of the tangent at the point, that is f dash, right? So you just need to find the slope of this line, that is going to be 8 minus 0 by 5 minus 1. That's it.
Ma'am, in the same process, actually, I got a doubt like where I
2,
am
ma'am.
finding
2,
the
2.
find.
Sorry, yeah. What is it?
Yeah, in
What doubt?
in the same situation, I got the doubt where I am finding that curve kind of thing. Is it going upward or downward kind of thing, which is not necessary. But to understand, I mean to say, can you draw a rough picture of
No,
this?
there is no information about the curve at all, right?
True.
There is
That's
no
what I got.
information at all.
Yeah, true. That's what I got some doubt kind of thing, ma'am. How we can make.
No, there is nothing given. You just know that it is differentiable at 1, so it doesn't have a sharp turn at 1. Because it's differentiable at 1, you can talk about the tangent at 1. That's it. There is nothing else given. And then you know that the tangent passes through 5, 8. That's it.
Ma'am, but the slope is coming out to be positive, which means it is an increasing linear line, right?
Approximately, that is my question.
At this point, only at 1 you know that it's going to happen that way.
Yeah, we have no values of x.
Excuse me,
we
ma'am.
have no powers, so we don't know if the curve is
Yeah,
square, x
at
cube,
1,
anything.
the slope is positive. That is all that you know.
Excuse me, ma'am.
Yes.
Ma'am, how you take f1 value?
When you draw the tangent to the curve, that point, what is the point that you draw the tangent? A comma f of a, right? This is where you draw the tangent. So if this is a, then this is f of a, that is f of 1. So 1 comma 0 means the second coordinate is f of 1, right? This is 1 comma f of 1, right?
Yes, ma'am.
Yeah, I haven't included any other questions, so you can ask me if you have any more questions.
Ma'am, can I ask one question related to L'Hopital rule, ma'am?
Yes, sure.
There is a question, and I'm not asking the question, ma'am. There is a question in graded assignment, question number 3, related to L'Hopital rule. The final answer that we are getting is 102b plus a. The final answer we are getting, but it is mentioned minus a. Rest of my friends graded assignment are having plus a only, and they are getting the right answer. But I guess there this only my set and the boys having my, same set as mine will be having this issue.
No, but I saw on Discourse someone had mentioned that if you solve it the wrong way, then you get this answer. But there is a trick involved. I don't remember which question because it's random. Question number 3 for you may not be actually question number 3 in the question paper that we have given. So I saw someone.
I am also getting the same problem. Minus sign is.
Yeah, someone had mentioned on Discourse that if you make a silly mistake, then you get this answer. But there is a trick involved. So if you do it right way, you get the right answer. Someone had mentioned this. It is just a change of sign that was happening.
Basically,
so maybe we can discuss that after. I will definitely work it out again today. If there is any change, no, actually when we saw that on Discourse, many had asked. So we already solved it once again to make sure that the answer is right.
Okay,
so it is
right.
Right.
So the question is right. Okay, we have to just make another attempt.
Yeah, the answer that is coming on the portal is right. So you need to try again and get the right answer.
Actually, what is happening that we are supposed to differentiate cos x, and when we differentiate cos x on both sides, it becomes minus sin x, and there is no plus sign remains afterwards.
Yeah, same thing happening with me also.
Okay.
Exactly same thing. There is no trick that looks like that. Whatever it is, it may not.
I think after having one differentiation, first differentiation, we have to change the look of the function. Means we have to manipulate. That is the thing which we are not getting. Actually, I'm also facing the same issue. after that question. So
Which kind of manipulation?
I'm not getting actually. I'm getting same problem, but I know that there will be some kind of manipulation that we will have to do. After that, we can get our answer. But I'm not
Yeah,
sure.
so this is what someone had mentioned on Discourse also.
Yeah.
Just a kind of hint, ma'am, not the answer. Just the hint we should follow.
Yeah. Also, I also want that, like hint or something clue.
Anyway, the solutions will be uploaded on the portal, no? So you can what? Can you just tell me what that question is? I'll just open it.
Yeah, I know, ma'am. It's a sin 4x.
Sine 14x
okay.
plus a sin x upon
Yeah,
17x
it's
cube.
actually, it will be different for everyone.
Different for each of us. Yeah.
Excuse
Sin
me,
4x
ma'am.
plus.
Yes.
Ma'am, the feedback submitted by students, the team is going to work on the feedbacks or no?
Yes, we are taking a look at the feedback.
Okay, thank you.
Ma'am, the timings of the live sessions are a little peculiar this time around. I mean, it's in the morning. Sometimes you're not able to attend those sessions.
Yes,
Okay,
ma'am.
so what
it should be in the evening, ma'am. Like in
I mean, in the evening or sometime after 4 o'clock should be fine.
Yes,
yes. 9:30 looks to be a little odd.
Actually, morning are fine for some of us.
Actually,
Yes,
many
sir.
working professionals
Yes,
are
exactly.
saying that evening it's difficult.
Correct.
So we are just experimenting. You can post your concerns. Then maybe if a lot of people say no, morning is not fine, evening is better, then maybe it will change. This is not a fixed time for the entire term. We just started off with this.
Ma'am, one thing I need to ask.
Yeah.
Am I audible? Ma'am, can you draw this B part? Can you draw the graph? I mean, I just want to see how does it works. Can you please draw it?
No,
for me?
that's what we were discussing. No, there is nothing I can draw, right? Like, okay, at 1, I know that the graph is not having a sharp turn. I don't even know, okay, at 1, the value is 0. That much I know. Yes. And then
passes through 5.
There is no, it's not going to be sharp. Yeah. And the tangent at 1 is going to pass through 5, 8. So, okay, the tangent is going to be something like this. So the curve will be something like this around here. Yeah, that's it. There is nothing else you can draw, right? Because only at 1 you know that the curve is differentiable and the value is 0, and the tangent at this point is going to pass through 5, 8. So yeah, this is basically giving you a linear approximation of the curve. What is it?
Curve could also be under the tangent line, for all we know.
Yeah, it could be like this also.
Okay, ma'am. Thank you, ma'am.
Yeah.
Ma'am.
Yeah.
I have a very silly doubt, related to this tangent. In week two, video number 4, professor is talking about the question of the tangent to the secant, right?
Okay.
Yeah. So, ma'am, my point is that in our school days, in trigonometry, we had studied about tan. So, tan basically is a short form of tangent. So, where we had studied tan theta equal to perpendicular by base, right? And
yeah, you'll have tan theta is equal to y by x and all
perpendicular by base, and the sec theta is nothing but the 1 by cos theta. So it is based by hypotenuse. So my point is this. My point is this: here, whatever we are talking, tangent and secant. So whether these two terminology have any correlation with this, or they are completely different.
So the slope of the tangent is tan theta.
Yeah, that's all.
Yeah.
Okay, slope of the tangent is tan theta, and then what about secant, ma'am?
Where theta is the angle with the x-axis in the positive direction.
What about secant, ma'am? What professor told that equation of the tangent to the secant. So whether that secant has any relation with sec theta, what we studied in trigonometry?
I don't know. I have to read about it. I don't know if there is any relation, but With respect to tangent, I know this. Yeah.
Okay, with respect to tangent, slope of the tangent is tan theta, right? So this is the relation.
Yes.
Huh?
Yes.
Okay, because in trigonometry also tan is basically the short form of tangent. So when we say tan
Yes,
theta,
yes,
this
yes.
is basically tangent theta, right?
Yeah.
Okay.
Activity
Okay.
2.4, question number 2.
Actually, the professor said that secant is the distance between the 2 points on the curve.
He said that's a line joining 2 points on the curve, right? But I'm just trying to understand the relation.
Yeah, but his question is it related to secant theta?
Yeah, sec theta. Yeah, secant theta has any relation to, you know, secant. Ma'am, you know, we are dealing with.
I think it is related.
Ma'am, we are.
Yeah, it should be related because the
Secant is
trigonometric
basically
angles are with respect to what happens within a circle, and then you talk about the secant of the circle. So definitely it should.
Ma'am, it should be because the distance is Euclidean distance. So when you take that, it would be equal to the secant.
Okay.
Means all these ones are interchangeable, ma'am. Sine, cos, tan, everything.
Yeah.
No, ma'am, secant theta, when we talk about theta, it is basically the angle between positive x-axis, right? And when we are talking about the secant, then it is basically the distance between those 2 points, right? So, okay,
yeah,
fair enough. You said that we have to figure it out what is the relation, ma'am. We can figure it out, then nothing like that. And then one more thing, ma'am, like in limit, we are studying trigonometric function, right? And even inverse trigonometric function. But these two topics have not been covered in our course. It might be that because of our past experience, we have some, now very limited idea, especially people who have covered it a long back. So
yeah, we got feedback about that too.
Yeah, why trigonometric function and inverse trigonometric functions are not part of this course, ma'am?
We'll consider that, but the thing is, there is a lot to cover, and there is very less time. So I don't think Maths 1 and Maths 2 is enough.
We could have introduced Maths 3 also, na, ma'am?
No. That will be some kind of
because Maths is the backbone of data science. Maths is the backbone of data science. So, by jumping out. Thank you, ma'am. Thank you. That's all from my side. Thank you.
Ma'am, my question is y is equal to ax square is the curve and tangent at a comma a cube.
Okay. Oh, what is it? Y is equal to x
ax
square. Then how much tangent at a comma a cube?
Y is equal to ax square.
Oh, okay. Ax square. Then.
So yeah,
what is
the equation of the tangent at a cube. I tried it, but I am not able to get the answer.
So the equation is going to be y is equal to f of a plus f dash of a into x minus a. F of a is a cube plus f dash of a is going to be a into 2x at a is going to be 2a squared into x minus a. This is a cube plus 2a squared x minus 2a cube, so 2a squared x minus a. This is the equation.
2a square minus a. Okay, fine.
Can we have a discussion on that question, which we were
talking
about? About L'Hopital. Question 3, graded assignment. I can tell you the question now.
No, I just quickly worked it out on my mind. The answer is right. Like, it is right. So you have to try and find the right.
Ma'am, we are not asking the answer, ma'am. Just give us a hint. What is the little bit of tweak we should just focus on? Just the direction, ma'am.
Yeah.
The question is, if f is continuous at 0, you need to find the value of something, right? That is the question, right?
Yes, ma'am.
You're given a function which is in terms of sine.
Yeah, sine 4x plus a sine x upon x cube, 4x cube. No, it's 14x cube.
Okay, as x tends to 0, you will get 0 by 0 form, right?
Yes, ma'am.
And then you will apply
L'Hopital's rule. Yes.
rule. Yeah.
Above
Okay,
which
shall I
question
stop
is also
sharing and
given.
then what is it?
Sure, ma'am.
Above in this page itself, I mean, in your presentation itself, such question is
Yeah, okay, okay. I
nearer
have
to
a
that
paper
question.
nearby. Let me solve it. You'll apply L'Hopital's rule. And then you will get.
Yes, ma'am. We will apply L'Hopital's rules afterwards, ma'am.
Okay, and then what will you do? Find the limit. The limit is that's it, right?
Sin x by x form, ma'am. We will find the limit for sin x by x form, which will become 1.
Okay. Okay. Can you apply the L'Hopital's rule?
Yes, ma'am. But after having first differentiation, it's becomes something upon infinity.
Yeah. So it means that you cannot apply L'Hopital's rule, right? Because the limit does not exist. So you cannot apply L'Hopital's rule.
But ma'am, they have told like the function is continuous. Means we have to assume that, and after assuming that, we have to
No, if
evaluate
function
something.
is continuous means that limit of f of x as x tends to 0 is f of 0. That is equal to b that is given to you.
Okay.
Yes, ma'am.
So can you apply L'Hopital's rule? That's the question.
Okay, ma'am. We are not supposed to apply L'Hopital's rule here, right?
Yeah, that's what we discussed today, right? The limit has to exist at some point. Only then you can apply the, like after how many ever times you get this indeterminate form and then differentiate and all that, the limit has to exist at some point, right? But
yes,
after the first differentiation, the limit is not existing, right?
There should be some value for the function, whatever it might be. That's the.
That limit should be equal to that L, some number L here. After you differentiate and find the limit, that should be equal to L.
Yes, ma'am.
Yeah.
Ma'am,
so try other ways.
2.4, ma'am, activity 2.4, question number 8.
Okay, can you quickly tell me what the question is?
Yes, ma'am, sure.
Okay, okay, I got it. I have opened it. 2 point, what is it?
Ma'am, it is question number 8, using the linear approximation.
No,
of
2.1,
2.4.
2.2.
2.4, ma'am, 2.4.
Okay, yeah. There's a change in the answer. It's 1.04. Is that what you wanted to ask? It was initially given 5.04 in the portal.
No, ma'am, I just want to know the approach.
Okay, so again, you need to find the linear approximation at 0, right? So what is the linear approximation at 0? How will you find the linear approximation at 0?
So, ma'am, we will take the equation here. F dash a x minus a plus fa.
One second. Yeah. So in this, your a will be 0, right?
Okay. A will be 0.
Yeah. So here a will be 0. You need to find that, and then they're asking for the approximate value of 1.01 power 4. So what value of x is going to give you 1.01 power 4? F of x is equal to 1.01 power 4.
So, ma'am, here we can say that x is gonna be 0.1. We are going to substitute x as 0.1.
0.01. Yeah.
Ma'am, 0.01. My mistake. Sorry, ma'am. Yes, 0.01.
Okay. And then you will substitute this in the linear approximation. Whatever value you get, that is it.
Okay, so a is gonna be 0 and x is gonna be 0.01. That's okay. Thank you so much.
Yes.
And ma'am, same question number 2, ma'am. Same 2.4.
Okay. Which one?
Question number 2. Same activity.
Which option? Which option do you have a problem with? Okay. Are you asking how to do?
Yes.
Slope of the linear approximation at m comma m is given.
No,
So
ma'am.
what is
That
the
is
slope?
first question. I'm asking second one.
Oh, that's third. Okay, okay. Tangent to the parabola at the vertex. You have to find the equation of the tangent. You have to find y is equal to f of a plus f dash of a into x minus whatever is the point they have given. X minus a, yeah.
Ma'am, in first question, we just put, I mean, a is gonna be -1. In M1, a is -1, right?
M1 will be the slope, right? So that's going to be 3x squared plus 3 at -1 will be 3 plus 3, 6, right?
Yes, ma'am. That's what. Okay. That's what I'm saying, ma'am. A is -1. Our a equal to -1, right?
Yeah. Well, you needn't find a and all, right? Slope of the tangent is nothing but the derivative of the function at that point. That's it. Why are you finding tangents? It's direct. Find f dash and then f dash at -1, 0 and 1. That's m1, m2, m3.
Okay. Thank you.
So the idea is this only, to tell you that the slope of the tangent is nothing but the derivative at that point.
Ma'am, graded assignment question number 4. I'm not asking about the technical concept involved, but I'm not able to understand this dt is equal to g function.
No, what is question number 4? Like, what is the question?
I'll read out. The distance traveled by a car after t minutes is given by the function dt, which is equal to g.
Okay. Yeah, okay.
So
I got the function.
my problem is this, what this g is and how do we understand it from the solution perspective. I get stuck because when we see g dash 1092, we have the concept of f dash thing in the mind, but it is not getting fit in this particular solution.
Okay, so they have given that the distance traveled is a function.
Yeah,
so,
distance traveled is not just a function of t, but it is also a function of some g, is what my understanding is.
No, it is g of something.
But in
g
of something, then it
instead
is
of g of t, instead of g of t, you have g of t squared. Say for example, instead of g of t squared, it can be g of t squared plus t cube. d of t. So that's a function of t, which is g of something. So this is that composition thing, right? F composite g, that kind of thing.
So whatever it is there in the brackets, we need to take as a function and we need to differentiate.
Yeah. Just like how we did e power x cube minus 1. That's the same way how you have to do this. We took e power x and then x cubed minus 1 as another function, no? And then we did the composition. That's exactly what you'll do here also. G is a function and whatever is inside the bracket, that is going to be another function. Say f of t is going to be that. So what you are given is g of f of t. Right?
okay. I mean, I understood, but I'll try to solve it then, basis what you have just told.
Yeah.
It will be difficult, but we need to try now. That's
yeah. What is instantaneous speed? You just need to find the derivative, right? You need to find out d dash, right? From distance to speed, how am I telling it correctly? Distance to speed is derivative, right?
So we have to find the instantaneous speed and dt is given, distance is given. So if we have to find the speed, we have to calculate dt upon the time, which is 5 in this case.
No. You need to find out dt
Just not just
by
derivative. I mean, it will
dt.
not just get solved finding the derivative. We'll have to divide by
Do
time
something more,
also.
is it?
Yes, I think
Yeah,
so.
yeah.
Yeah.
You have to do.
Divide by
Okay.
time, which is in this case after 5 minutes.
Okay.
Hello, ma'am.
Yes.
Hello.
Yeah. I can hear you. Tell
Ma'am,
me.
I have a dot in activity 2.2, question number 2. Why is option 1 is not correct?
1 second. Activity 2.2. Question number
2.
The differentiability one.
Yes, ma'am.
Which of the following? Okay. Why is option 1 not right, is it?
Yes, ma'am.
Okay. F of x is equal to c. What is f of a plus h? What is f of a plus h?
Sorry, ma'am. Actually, I didn't understand the.
You're talking about which of the following options showing stepwise solution to check whether a function is differentiable or not. That question, right?
Yes, ma'am. Yeah.
So option 1, you need to check whether f of x is equal to c, where c is a constant, is differentiable or not, right?
Yes, ma'am.
So first you use that limit definition. Limit as h tends to 0, f of a plus h minus f of a by h. So what is f of a?
F of a is basically c.
Yeah. What is f of a plus h?
C plus h.
No, why is it c plus h? The function is a constant function and it is equal to c for all values over the real line. So a plus h function value at a plus h is also going to be c, right? Why will it be c plus h? It's a constant function.
Okay, I think means I'm thinking that c is some variable. That's why.
No, c is a constant. Take for example f of x is equal to 1. Then what will f of a plus h be?
It is also 1.
Yeah, that's it.
Ma'am.
Will the same logic will apply for the question
Yes.
what we have just seen now, ma'am? Means grade assignment question.
Which one?
We have just
Graded assignment.
Graded assignment question just we have discussed. The same logic will apply here also.
Here we are finding the derivative, right? There we are
D of t is nothing but a limit, no, ma'am.
Oh, the instantaneous speed one. Okay. Yeah, maybe you should try it out. Okay, you're telling we can find the speed by taking limits, is it? Applying the definition of limit, is it? Is that what you're telling?
Differentiation purpose is nothing but finding a point kind of thing and tangent. So these two aspects, that's okay.
No, I still have a feeling that that question is very simple. Like d of t is like f composite g, and then I think if you differentiate, you should get the answer. Like if you do the proper differentiation, in the sense f dash of g of x into g dash of x. That thing.
The basic question is how to substitute the values kind of thing. There probably we are getting confused. I think. Anyways, it will be cleared after a day or two. There is no problem with this.
Yeah, maybe you can try again. Anyways, the solutions will be uploaded. So maybe you might feel that, oh, this is very simple and I missed it, kind of. It might be that simple.
Ma'am.
Where can we get this PDF, the one that ma'am uses? Oh, the one that I have written on, yeah, it will be there in the supplementary contents. Yes. Yes, Krishna Kumar. Yes, please tell me.
Ma'am, can you explain activity 2.1 question number 5?
Activity 2.5, is it?
No, ma'am. Activity 2.1 question number 5.
Oh, activity 2.1
1.
question number 5. Okay. Which of the following options is true? There exists a continuous function. So you want to understand what is asked of the question, is it?
So actually, how can we ascertain which statement is true? Reading the first statement, how do we figure out whether there exists something like this or not?
Okay, so you are asked to find is there a continuous function from closed interval 1 comma 5 to closed interval 1 comma 7 such that f of 3 is equal to pi? Can't you just put f of 3 is equal to pi and draw a straight line or do anything like that and draw a continuous function from 1 comma 5 to 1 comma 7? What is the easiest continuous function that you can think of? The constant function, right?
So first of all,
Define f
this
from
1,
closed
5.
interval 1 comma 5 to 1.
1 comma 5, what does this mean? That's the limit on the
It's a
x-axis,
closed
or is it
interval 1
xy?
comma 5.
It is a domain. 1 comma 5 is a
Yeah,
domain,
it's the domain. It's
and 1
a
comma
subset
7
of
is
the
the range.
real line.
Yeah.
1 comma 7 is not the range, it's a codomain, right?
It's a codomain.
Yeah.
So can we take the function as a constant function like fx equal to pi? And whether we say
Yeah.
f of 3, f of 8, it's the same thing.
Yeah.
Okay.
For the second option, you're given two different values, like f of 1 is something, f of 10 is something. Take those 2 points and then draw a line, no? Between those 2 points. That will be continuous, right? Yes or no?
Yes, and is defined in the codomain also.
Yeah. And then third option is there exists a non-constant continuous function f from R to R which is bounded. What is the easiest that comes to your mind?
Sin x?
Yeah, sin x, cos x. Option 4, there exists an unbounded continuous function from 2 comma 3 to R. What is the first unbounded continuous function that comes to your mind?
Tan.
Okay, fine. Easier is 1 by x, right?
Yeah, or ex or log.
Yeah, you can do all that and then shift it. Take 1 by x and shift it. 1 by x is you want it from 2 comma 3. So 1 by x is going to be bounded in 2 comma 3, but make it 1 by x minus 2. That's it. That's going to be unbounded, right?
But tan x is not bound, I mean, is not continuous at n pi by 2 where n is odd, right?
Oh, yeah, here we want a continuous function. Yeah, sorry.
Yeah.
Yeah.
It will be uploaded. Yes, if it is uploaded. Yes, it will be uploaded.
Ma'am, for activity questions, we are
anything
not
else?
getting the solutions.
Yeah, you should be trying it out. And anyway, we are helping in the live sessions, right?
Yes, right.
With respect to activity questions. And even if time is not convenient for the live session, it is always there on YouTube. So it'll actually be going live now, so it'll anyway be on YouTube. Okay, so shall we close?
Yes, ma'am.
Yeah. Okay then. See you all. Bye bye.